So that's what we're going to look at for section 2.1. We're going to look at frequency distributions and the different graphs you can make with them. And so, again, the reason why we do this is because it can be difficult to see patterns. If someone gave you a data set with 250 people in it, and it's just like person 1, all their data, person 2, all their data, person 3, would you be able to see patterns from just looking at raw numbers? You think? Probably not. Because person 1's data may have their age, their race, their gender, their state they live in. Whatever you're researching, it's everything they've collected about person 1. Everything they've collected about person 2. You're like, this makes, looking at it, it's like, okay, person 1, he's from Texas, the best country, state. Nice. I'm sure I'll probably like him. How he compares to everybody else, I don't know, just looking at his numbers. So, first thing we can do is create a frequency distribution. We're going to start off with some definitions. If you need notebook paper, or does anyone need a journal? If you want a journal to write them in, but you didn't get one, because I've got some extras. Okay. Definitions. A frequency distribution, that's our first one. Frequency distribution. Frequency distributions are tables that show classes or intervals of data entries with a count of data entries with a count of the number of entries within each class. So that's what a frequency distribution is. The frequency, you may have already been able to gather this, but the frequency, which we use the letter F for, we just use the letter F for frequency, of a class is the number of entries in that class. Okay. So what a frequency distribution looks like is a 2-column table. So we would have like a class, and then the frequency. So like let's say from 1 to 5, there were 5 people that had an entry there. What this means, if let's say this was the number of dogs you have. That's saying that 5 people have anywhere from 1 dog to 5 dogs. We don't know how many dogs these 5 people have. It's just somewhere between 1 and 5. Like if you were to sort them out, you look, okay, person 580 has 4 dogs. Okay, well, I'm going to go put them in that bucket. A class is like a bucket. So 6 to 10, 8, 11 to 15, there's 6, 16 to 20, there's 8, and we'll just stop there. This is an example of a frequency distribution. Okay, so some things to point out here. These pieces, the 1, the 6, the 11, the 16, those are your lower class limits. Lower class limits. This is the least number. That can be in that class. So our lower limits from this table would be what? 1, 6, 11, and 16. Those are our lower class limits. Then we have the opposite end. You got your, that's not a good color to highlight in. Let me try maybe a green. Let's work. There we go. 5, 10, 15, 20. Those would be called our upper class limits. They are the greatest number. That can be in the class. Scroll. Let me scroll down some. There it goes. Okay, so our upper class limits in this case would be 5, 10, 15, and 20. Those are our upper class limits. Then we have something called the class width. Class width. This is the distance between the upper or you could say the lower, they're same concept, limits. Okay, so if I were to look here, I just want to look at either the upper or the lower to get my class width. So what's the distance between 5 and 10? Plus 5. What about between 1 and 6? 5. See, they're the same. That's our class width. So, just as an example, class width equals 5. Notice we're not saying 1 to 5, and we're going to say, oh, that's 4, there's 4 in between. We're not going and saying there's 4 in between here. No, we're looking above and below. That's class width. And then you have the last little definition here is the range. The range is the difference between the difference between the lowest data value, which we call the minimum, and the highest data value, which we call the maximum. Okay. Now, with just this frequency table, I don't know, there's no way I can calculate the range because I don't know what my minimum is. I know it's going to be somewhere between 1 and 5, but I don't know where. Same with the maximum. I know it'll be somewhere between 16 and 20, but where? So we can't exactly calculate the range for this example. Okay, so now, how do we make one of these? Okay. How do we make one? So let me scroll. There we go. There are 5 steps. 5 steps to make one. How to make a frequency distribution. Step 1. We have to determine the number of classes. How many classes do we want to have? Now, this can be as small as 5, or should be between 5 and 20. If we have less than 5 classes or more than 20 classes, then it becomes hard to see a pattern in the data. Because if we have less than 5, we've got too few groups to really see what's going on. But if we have more than 20, we've got too many groups. Again, it'll be hard to see what's going on. What I will say about this is, as far as this class goes, you really won't have to worry too much about step number 1, because I will tell you create this distribution with this many classes. So you'll just need to know to read the problem and say, hey, he said create a distribution with 7 classes. Okay, step 1's done. 7 classes. So I'm going to say for class, this will be given. But it'll be between 5 and 20, because if it's not, there's going to be, it's going to be hard to see patterns in the data. Okay, step 2. We need to determine the class width. On that red sheet I gave y'all, that actually has the formula for class width. So you don't have to remember the formula. It's on there. But we'll write it down. For class width, that formula is the range over the number of classes. Is that what it says on your formula sheet, or does it say something different? For those that are looking at it. That's what it says on the formula sheet? Okay. What did we say range was, if we look at our definition of range? Okay. So another way we could say this is we take our max minus our min and divide it by number of classes. Okay. Once we get our answer, we're going to always, every single time, whole number, decimal, doesn't matter, always going to round up to the next whole number. I'm putting that in red because people forget it every time. Always, always, always round up. So if I got a class width of 6.2, like if I calculated this and got 6.2, what would that be? 7. Always round up. If it was 7.8, what would that be? If it was 5, 6. We always want, and the reason we do this, if we just said, oh, it's 5, it's going to be 5 on the dot, you'll get to the end, like you're creating everything, it's good, and then you're like, I don't have enough classes for my maximum. My maximum's like off the chart. So by us always rounding up to the next whole number, even if it already is a whole number, you're guaranteeing that when you get to the end and you get to your maximum, that maximum has a bucket to go into. You're not going to be like, uh-oh, I ran out of buckets. Sorry, maximum, you just sit out. You don't get a bucket. So always round up. Okay, step 3. Then we have to determine the class limits. So you're going to start with the minimum as your first lower class limit. class width. Until you reach the number of classes needed. So that'll get you your lower limits. And then for your upper limits, it's honestly hard to put into words. So we'll just have to see it in action. Like I said, it's kind of hard to put into words. We'll have to see the upper class limits in action to get those. Okay. Step 4. So make tally marks. For each entry in the appropriate class. And then step 5 is to total up the tally marks for each class. These are the steps that we're going to take to make a frequency distribution. Okay, so now, we're actually ready for our first example, almost. I'm going to go on and write example 1 right here. But, for this example, you're going to need your cell phone. And you're going to need to be logged into your calculator. So you'll want your calculator, and I'm giving you permission to get your cell phone, because you'll want your cell phone. I want you to count how many text messages you sent yesterday. So, you'll actually count how many messages.
Wait, every single message or just the people we've texted?
Every single message.
Well, I have work every day. You might as well tell me 1,000 at this point. The work group has blew up, so.
Well, it's how many you sent, not how many they sent you.
No,
but
I
how many.
haven't texted back every time.
Gotcha. Okay, so you'll want to log into your calculator. Once everyone's logged in, I will send you the quick poll for it. Does everyone log into their calculator so I can send this quick poll out? you able to log in, Alejandra? It's showing you more. Oh, there it went. Okay. So while y'all are doing that, I'm gonna count how many I sent yesterday.
Like it's like the actual sizes. So like when we write it down here, it's not like the data window. I thought if I remember I'm too stressed for classes. They were like, I'll submit the wrong number. I'll submit the wrong number.
Submitted the wrong number? Okay, let me see. I may be able to.
166. From work. Work. I'm not even all work.
I may be able to send it back to you.
Let me see, check my.
You say what?
That one's.
It's not letting me. We can fix it. If you know these numbers you sent. Okay, we can fix it. Anyone still trying to figure out how many they sent yesterday?
Did you get?
It's not showing me whose I got and whose I missed. Trying to look. Oh, there it goes. Let's see. Okay, so we're still waiting. Let's see, they're testing. Still waiting on 2. If y'all, okay, so where we're going with this, just so y'all know, is on this data sheet that I gave y'all, like it's just a single page with, looks like there's 4 blank tables on it. We're gonna write down just the numbers, not names, We're gonna write down the numbers. So like if y'all, in that first box, if y'all wanted to put mine, since I didn't submit a quick poll for me, I sent 11 text messages yesterday. So that, if you want to put that in the first box, that way you all have my data, you can. 11. That's how many I sent. That sounds bad. You sure?
Yeah.
Okay, so it looks like y'all are all submitted, so I'm going to stop poll. And then look at, open the data. Open. It's not wanting to open. Come on. Maybe. Maybe not. Maybe we do have to see names. I don't. There we go. That's all it's gonna do for me. Really? Okay. Evidently it's acting all kinds of spazzy. So. Okay. Unfortunately, I guess we're gonna have to see names. Unless you want me to hide names.
My number is wrong anyway, so.
Okay, yours is right here. What should it be?
166.
166? Okay, so it's not gonna let me. Now it's hiding it. Okay. Okay, let's just go down and we'll write them in. Unfortunately, we're gonna see names. Let's go down. I'll give y'all a minute to fill these in. When y'all get to this one right here, that's clicked. That should be a 166.
Mr. Schwartz, which way we write it here?
You can go across and then down. It doesn't really matter.
Do it at 11?
You can. 11, yes. Okay. Wait. Are we down through at least this bottom one, or someone up higher? I can scroll all the way down? Okay. I'm gonna go have that 9. Take it down even further. There we go. So there's all of them. So how many boxes did y'all have blank on your table? 3. Yeah. Did you get my 11? Okay. Okay, so there's our data that we're going to use for example 1. We're going to use this data for example 1. So keep it out. We're going to need it. That's what we're using. Last semester, or was it last semester or last fall? One of the semesters, someone like counted 350 text messages in one day. Okay, so example one, we're going to construct a frequency distribution with 7 classes. Construct a frequency distribution with 7 classes from the cell phone. Actually, I called it text message on the sheet. So, text message data set. Okay. Okay, so from our data set, well, let's walk through it. Walk through the steps. Step 1, what do we have to do? For making a frequency distribution, what's step 1? So how many classes do we want? 7. Okay. Step 2. Okay, class width. So what was our maximum? 166. Okay. The minimum? 0. Divided by the number of classes? 7. So 166 minus 0 divided by 7.
24.
What was it?
24.
24. Was that like already rounded?
No, it's around that. It actually went just 23.7.
23.7. Okay. That goes to a class width of 24. Okay. So now the next 3 steps actually kind of happen in a chart, if you will. So we want to start making our chart. We're going to have the classes here. And then a spot for our tally. And then the actual frequency itself. Okay. I guess you could say this is like step 3. This would be step 4. This would be step 5. So for the classes, it says for our first lower limit, we have to pick the minimum. So what was our minimum? 0. So that means that's going to be our first lower limit. Okay. What was our class width? 24. So I have to add 24. 0 plus 24? 24. Plus 24? Plus 24? Plus 24? Plus 24? 120? Am I at the 7 classes yet? I need one more, so plus 24 again. Okay, so those are all my lower limits. Now I need to go get my upper limits. On the upper limits, we want to make sure they don't overlap. So if I have 24 messages here, what's the maximum I can have up here? 23. Okay, so then my next limit would be 47, and then 71, 95, 119, 143. Yep. What was it? 169. 167. Because each of these have to also go up by 24. So when we get down to this last one, I still have to say plus 24, which gets us 167. Okay, that's actually really the hardest part of creating these distributions, is getting your classes set. Because now we go through and we do the tally marks. So that's where we go through the data, like our first, on my table, my first entry was the 11. So which class does that go in? First one. And then we have a 15, also in the first one. A 31. And we're going to keep going in that manner until we get all of them filled in. So I'm going to quit talking, give y'all a minute to do your tally marks, and then we'll compare ours. Okay. So then once you get your tallies, then you just kind of add them up. So like for mine, did y'all get 12 for the first one? Yes. And then 4, 2, 4, 0, 1, and 1. There's our frequency distribution. Okay. Every time this example always shocks me, because it like, you as teachers and even as society is like, oh, the younger generation, they're always on their phones, they're always texting, they're always doing this. And that's like, how many did a lot of the class sent less than 24 messages yesterday? Granted, that's text messages. Y'all are probably sending messages other ways, not through text, like Snapchat and all that stuff. But yeah, that's one way if a company wanted to like really try to push the status quo, because that's what people do in stats. The unfortunate side of stats is that you can make stats say whatever you want them to say. So they could take this and say, look at our sample. They say kids are always on their phones. Yet, half of them sent less than 24 messages. So, how can you say they're always on their phones? This is showing otherwise. It's like, that's their narrative that they want to put out there, and they can just use the stats to do it. So, that's one thing you have to look out for when you're looking at stuff like that. Okay. Questions on that example? Questions on building a frequency distribution? Okay. Let's expand it. Let's expand it. So to do that, we're going to need some more definitions. We're going to need a midpoint. So the midpoint of a class, let me do this. This is going to be more definitions. We're going to have midpoint. The midpoint is the sum of the upper and lower limits divided by 2. So if you're a formula person and you like formulas, I don't know that this one is on your formula sheet, but again, if you're a formula person and you like using your formulas, the midpoint is going to be the upper limit plus the lower limit all divided by 2. And then we have relative frequency. There's midpoint. We got relative frequency. Relative frequency is the proportion of data that falls into the class. Proportion of data that falls into the class. So again, if you're a formula person and you want a formula for this, relative frequency is equal to the number in the class over the sample size. Or another way you could see this is X over F. Actually, I said that wrong. That is one way. I think the way that's on your chart, if it's there, is F over N. So the frequency divided by the sample size. Remember, sample size is lowercase n. Okay. Then we have cumulative frequency. This is the sum of the frequencies of that class and all lower classes. So think of this as like a running total. The cumulative frequency is like the running total. And then the last definition for this bit is class boundaries. These are the numbers that separate classes without forming gaps. So again, if you're a formula person, the lower boundary is the lower limit minus 0.5. And the upper boundary is the upper limit plus 0.5. Okay, so let's look at an example. Example number 2. We're going to create an expanded frequency distribution. Using the data in example 1. So we're going to want a big table here. A table that's going to have 1, 2, 3, 4, 5, 6 columns. In the first column, we're going to have the classes. I'm going to probably need y'all's help on that one, so I don't have to sit there and scroll back and forth. Then we're going to have the boundaries.
I'm sorry, Anna. Do you remember what year you got those calculators? I'm just trying to cycle out some of the
The white ones?
What year you got them?
If it wasn't last year, it was year before
So
last.
they're about 2 years old?
Something like that.
Okay, we are getting new caps.
Oh, okay.
Thank you, sorry.
That's okay. Okay, so can y'all help me with the classes? What were our classes? 0 to 23, okay. And 24 to 48 to 72, 96, 120,
143,
and then 144, 167. Thank y'all. Okay, so then we're gonna have boundaries there. And then our frequencies. If y'all can help me with those two, that would be appreciated. I think it was like 12, 4,
2,
4.
0, 1, 1.
Okay. There's our frequencies. This is going to be the midpoint. Then we're going to have relative frequency. And last but not least, cumulative frequency. Okay, for the boundaries, let's start there. Those are the easiest to do because all we're doing is taking the class boundaries here, subtracting 0.5 from the lower one, adding 0.5 to the upper one. So this would be like negative 0.5 to 23.5. I subtracted 0.5, added 0.5. I'll kind of do like a little refresher here. Minus 0.5, plus 0.5. Okay, so 24 minus 0.5 is 23.5. And then we're going to have to 47.5. 48 minus 0.5 is 7.5. Are y'all seeing a pattern? Yep. The upper boundary is the lower boundary of the next class. So 71.5 to 95.5. 95.5 to 119.5. 119.5. I totally did that. Backwards order. To 143.5. And then 143.5 to 67.5. That's your boundaries.
Wouldn't the last one just be 143 or no?
Which one?
Oh, the very last one?
This one down here?
Yeah.
It can't be because we have to subtract 0.5 each time. We're talking about right here. Why is it freaking out? We're talking about right here.
Mm-hmm.
Yeah, we have to subtract the 0.5 from the 144. And the way you can tell you're doing the boundaries right is once you go through and subtract 0.5 and add 0.5, if these line up, that's a good thing. That's what you want. You want those to line up like that. Okay, midpoint. We're basically finding the average of the class limits here. So it'd be like 0 plus 23 divided by 2, which gets us 11.5.
Yes.
Then we do 24 plus 47 divided by 2.
Wouldn't that give you the same thing?
No, it wouldn't be 11.5. 35.5?
Oh, you have.
I think it is. And then we do 48 plus 71 divided by 2. 72 plus 95 divided by 2.
You have 3.5.
83.5. Okay, I'm gonna pause here for a second. Do y'all notice anything between the midpoints? How far is it here? 24. How far is it here? How far is it here? Where did that 24 come from? That looks familiar. That's our class width. So on midpoint, you don't have to necessarily sit there and go, this plus this divided by 2. This plus this divided by 2. Once you get your first one, you can start just adding your class width to it. So I could just go 83.5 plus 24 to get my next one. 107.5 plus 24 plus 24. Now, if you don't think you're going to remember that, then by all means, please, just add them up and divide by 2. Okay, relative frequency. Well, to do relative frequency, I need to sum up the frequencies here. So how many do I have in total? If I add these up. Yep, it is 24. Okay, so for relative frequency, I'll take the frequency divided by my total. So 12 divided by 24 gives us 5. 4 divided by 24. Let's round the 2 decimal places. Is it 0.17? Okay, 2 divided by 24. Okay, we already know 4 divided by 24 is 0.17. That's going to be 0. 1 divided by 24. 0.04. And again, 1 divided by 24 is 0.04. Now, a way you can check yourself, before you wreck yourself, add these up that we just got. And what do they equal? One. As they should. Because this is the proportion of the whole, that's that frequency. They equal 1. Now, cumulative frequency. This is like a running total. So, in this first class, my cumulative frequency would just be my frequency. 12. For For the next one, it's a running total. So now I have to do 12 plus 4, which gets me 16. And I gotta do 16 plus 2. 18 plus 4. 22 plus 0. Stay the same. 22 plus 1. And 23 plus 1. What should this number match if we did it correctly? Yeah, these two should match. This one and this one should match. So that's one thing I like about this table is it has a bunch of ways to check your processes to make sure you're doing them right. So what are some observations we can make about what's going on here with the text messages? What are some observations you can make from this table? I said one earlier. Half the class sent less than how many messages? Yep. And then the vast majority of the class sent less than how many? We can even go that far. Vast majority sent, less than 95 messages. So those are some observations you can make looking at the table. We're not going to have time to do this today because I don't want to. No, we're probably already tired, but we've got several graphs we want to make. We'll do that tomorrow. We'll do all the graphing tomorrow. The homework, you can get a good bit of it done if you're the type that you like to start on it when things are fresh. There are several questions asking you to just do the distributions, calculate the midpoint, stuff like that. It will be due on Tuesday, because we'll finish 2.1 tomorrow. That formula chart, I haven't really mentioned it much. Keep it in a safe place and don't write anything other than your name on it. Because on test day, in 2 weeks, you get to use it. As long as there's nothing written on it, you get to use your formula chart.